you please speak with, for the sake of everybody. Thanks.
Okay, so I'll be talking about, this is a local government session, so I'm talking about helping local governments use low-cost environmental sensors and air quality sensors particularly. We'll skip through that, and sort of at the beginning of this, we were talking to a number of different local governments in Australia, in New South Wales, which is a state, about air quality. A lot of them had air quality issues. At that time, it was around the time when we had a lot of bushfires, so most councils, so local governments, had problems with air quality from fire. But also, they had a range of different air quality issues, from transportation-related air quality issues to industrial pollution, from smoke, agricultural smoke, coal dust. There's a whole range of issues that they experienced. And we basically said, if you've got a problem with air quality, what is it? And secondly, have you heard about low-cost environmental sensors? And are you comfortable that you can actually use them? And if you're not comfortable, then where do you think you need assistance? And so pretty much all councils said to us, we've heard about these sensors, but really don't know how to choose the right sensor for a particular application. We don't know how to interpret the data. We don't really know how to install them and where to install them, how to operate them, how to maintain them, how to calibrate them. So there was a lot of interest in using these technologies, but not a lot of understanding about how to do it. So this project really is about not developing technology, it's about helping local governments use the technology. One question, of course, is that what can local governments actually do about air quality? And there's some various things, you talked about a few there, Amanda, and there's other things that can be done. They can't put out bushfires necessarily, but they can do mitigation. They can do community education. If it's industrial dust, they can collect information and then engage with the local EPA, for example, at the state government level. So there's a number of different things they can be doing. And so one of the early questions that most councils had is, what could we do? We know we think we have a problem. We don't know whether we have a real problem. And if we do, what can we actually do about it? So this project helps them work through a process to understand that. The project had 4 objectives. The project itself is an 18-month project. It was a $2.4 million Australian project in New South Wales. And it had 4 objectives. So the first one is to help the local governments by developing some best practice resources, which cover those areas I talked about. So sensor selection, defining your air quality issue, using the sensors, interpreting the data, etc. So the first objective was to produce a series of documents, resources. The second one was to actually have the councils involved in the project learn by doing. So the project team, and I'll talk about them in a minute, weren't going on site to do the work. We weren't installing the sensors. What we were doing is saying to the councils, we'll help you work through the process to define your issue, choose the right sort of sensor. And in some cases, it might be a $300 sensor, but in other cases, a $10,000 sensor. So it's really helping the councils do it. They were learning, they're building capability, and then we're learning from that experience and then putting that back into the best practices. So that's the second objective. The third one was we anticipated that there'd be a lot of interest, an ongoing interest in sharing experiences. So the third objective was really to develop a collaboration hub and then work out how we can keep this going after the project's completed. And then fourthly, the state government had a great deal of interest in understanding, can we access the data from these sensors? The sensors themselves are from a range of different companies, different manufacturers, different data formats, different APIs. So they're quite different, but what they're measuring is pretty much the same. So the fourth objective was to see whether we could extract the data from these sensors and then make that available as a common air quality data resource for researchers and for policymakers. So I think I've talked through the overall approach, which is develop the material, learn by doing with the local governments involved. There was a series of workshops. We had some information sessions every couple of weeks. We helped the councils on the phone. We had them attend workshops in person in Sydney. And as far as the project participants are concerned, the little stars of the local governments, they came and went a few times. So we had councils who started with the project, and then during the project they found that they had a change of priorities. Floods, we had a lot of floods in New South Wales halfway through this, so some of them got distracted by flooding. We had people who were champions in their council start the project and then they'd leave, and then the replacement person wasn't interested, had other priorities. So there's quite a lot of flux within local government. So we had local governments, both metropolitan and regional, and a few others. So Darwin, who we heard about before, Darwin had heard about the project and said we'd like to be part of this too as an observer council. So they joined and as an observer. They didn't participate directly, but they were very interested in what we were doing. And then we had a number of different research organisations provide the expertise. So ANU, and we've got a couple of people here from ANU, Satiris and Nigel. Ricardo from UNSW is involved from the heat perspective. University of Sydney, University of Western Sydney Uni. All of these universities providing different types of expertise, from business case development and economic understanding to air quality science to sensing and data analysis. And it was led by the New South Wales Smart Sensing Network, which is a research innovation network in New South Wales. The overall process that we used to develop the methodology for councils was what we called an impact planning cycle. It's fairly straightforward, starting with defining business needs and then working right through to, if you have data, what we're going to do with that data, and then through the practical aspects of implementing sensors, operating them and calibrating them, and then interpreting the data. All of this stuff is available on a website, project website that we've established. We're finalising some of the documents, but there are documents on there now. That's the openair.org.au website. And really, a lot of this stuff is generic to other types of environmental sensing and to smart city type initiatives. So a lot of the work is applicable in those other areas too. The feedback was pretty good. I mean, it's around capability development, really, this project. So two of the councils here, Parramatta City Council, which is a fairly large metropolitan council, and Sutherland, which is a smaller council in Sydney, both provided a few words around the project to say, what do they think of it? And you can see here that I've highlighted in red sort of some of the benefits that the councils saw. And again, it's not so much it's the technology, it's how to use the technology. So it's technology adoption is the main thing, and building capability within local government. What they really appreciated on a lot of the calls was the in-depth understanding of the air quality science that the team provided to them, and heat, for example. So they'd heard about these things, they had a very rough understanding, but when we explained it in detail, they had a much better appreciation. The fourth objective was to see if we can collect the data from these sensors and make it available to a broader audience. The local governments involved were more than happy to share the data. What we ended up with was a number of different makes of sensor, so 3 different types of sensor. In the end, was all we needed to provide for, or we recommended to the councils that they acquire. So the purple air sensor is it's a $300 sensor. The AQ mesh is about a $10,000 sensor, and the clarity sensors are sort of in the middle there. They measure different things a little bit, but they're comparable. The sorts of things that the councils were measuring was, as I said before, it's anything from transportation to smoke to dust to heat. So we had these 3 types of sensors installed at the local government areas. Each of those companies has an API to share the data in their own format, and they're quite different. But the underlying data is the same. So it's a PM 2.5 measurement, or it's a temperature measurement, or a relative humidity measurement. And so what we developed as part of the project was a system to ingest the data from the commercial providers, store that in a database, and then harmonise that. So take that data and then store it in a common data schema, and then make that available through a new API that we've developed to make that available to the external system. So this is prototype, and it's working. And so now what we're looking to do is see how do we make that more robust and then widely available. Observations. So I mentioned that there's staff turnover due to various circumstances, which always holds things up. The project plan I developed at the very beginning was a giant Gantt chart. Within about a month, I had to throw it out because all the assumptions were wrong. And people didn't do things when I expected them to, or when they said they would, for these reasons. So we need to be adaptable in these sorts of projects. And when there's more than a dozen organisations involved, it's a bit of a moving piece sometimes. The local governments had widely varying technology capabilities, and so the procurement model that we recommended changed too. So the more advanced councils had an IT department. They knew how to ingest data. They had things to learn, but they were okay with the technology. But the smaller councils, often they don't have anybody who's really skilled at this. So the procurement model for them was to recommend that they outsource or they just buy a turnkey solution from a company, potentially with someone else installing the sensors and operating them. So procurement varies depending on the local government capability. And I think in terms of how much time have I got? Only a minute or so, I think.
1 minute 20.
So this, as far as the sensor selection, where it started with the councils was it often starts with, we've had someone come to us with a sensor and recommended we buy it. Let's just try it. And sometimes we find that's not the right approach because the sensor may not do what it needs to do, what's needed. And so sensor selection is difficult for councils. So this helps them work through how to go about making an intelligent choice on that. Future vision is that we have this sort of technology in routine use. It's not at the moment. So the local governments should be using this sort of technology. And so the recommendations we're coming up with are really targeted at state government to try and foster widespread usage of this technology, and also to make sure that the collaborations that are needed between local government and state government and community are informed by the data. Because up until now, a lot of the councils that said, the community has said there's an issue with air quality, but we don't know whether there is or not. Or we think there's a problem with this industrial, commercial site, but we really don't know. So we can't engage with an EPA in any sort of informed manner. So the vision for this is to take this sort of technology because it's affordable and then have that informed collaborations. There's a series of recommendations being written up right now, 35 specific recommendations in a number of different categories, which is really promoting the use of this technology. Please stop. You could read the rest yourself.
Thank you, Peter.
That's pretty direct, that please stop.
We just wanted to have a couple of minutes for questions.
Okay.
So I think this is a very fantastic example. So,
first of all, thank you for this work. I'm really excited to see the best practices implemented.
Yeah.
We'll definitely have a look. Did you encounter any councils that were skeptical of these low-cost sensors? How do you form a narrative around this? Because, was there pushback specifically for the low-cost sensors?
No. One of the ways we help them understand the limitations of these compared to what they'd heard about from the state government is that the US EPA have a tiered framework of sensors, where a tier 4 is a state air quality monitoring standards-based system, very expensive, very accurate. That's a level 4. Level 1 is an educational, build-it-yourself type sensor, and there's a couple of stages in the middle. So most of these are tier 2, which is it provides information, helps identify hotspots and patterns, but if you want to make it, it's not good enough for compliance purposes, for example. And so that's when we'd help them understand that you could use a sensor to understand where there might be issues, and then go to EPA if you needed to, and they would bring in the higher quality sensing if that was what you actually needed, for example. So no, they were fine with it because it's cheap. It's practical, and the biggest issue with the state government-run sites is that they provide a very broad ambient air quality over a broad area, and they're installed away from busy intersections, away from CBD areas, and the councils could install these sensors where they knew that, or where they thought, or where they knew there was an issue at a very localised level.
in the back, sorry.
Richard?
Okay, just one comment. In addition to what Peter said, local sensors, which we are trying to do now, use them as for data fusion in conjunction with our monitoring station, which we have, to support our forecasting. So local sensors, at the moment, everybody sees as reactive load, but it's going to be used for predictive functions.
I think just in the interest of time, perhaps,
Okay.
your questions to Peter
Afterwards.
in the break. Thank you.
So we'll move to the next presentation by Professor